Good morning, people of the internet. This is Chris from Bedford Heights Auto Service. Well, today we are working on a 2001 Jeep Cherokee Sport. It has the 4-liter inline V6 engine, one of the best engines that Chrysler ever made, at least in my opinion, as well as a lot of other people's opinion. The reason why the vehicle is in here today, and I will first apologize, I am doing this freehand, so I'm going to try to keep my camera as steady as possible. The vehicle does not have any heat. Well, the customer has had several things attempted to be done on the vehicle. A new thermostat has been installed on this vehicle. The cooling system was apparently flushed or back flushed several times. More like a sales technique on that. The customer still doesn't have any heat. One comment that the technician at the other repair facility said was when he was running the engine, there was nothing but bubbles coming out of the radiator here. Now, bubbles are obviously trapped air in the cooling system, and you will obviously have a bit of bubbles in there after you say something like a thermostat, or you flush an antifreeze system, however it may be. The system has been opened, so you're going to have naturally a little bit of bubbles in there, but they will escape by the time the engine warms up to normal operating temperature. However, according to this technician, there was nothing but bubbles continuously. So, there is air somewhere entering the cooling system. Now, that could be a number of issues: radiator, a hose, a cracked cylinder head, a blown head gasket, a bad heater core. There's so many things that could possibly be. So we're going to start with the basics. Well, we open up the radiator cap and we look inside of here, and I'm not sure how well you can see this or not. That antifreeze in there, for being back flushed, that looks nasty. That looks like a rusty, I wouldn't say necessarily milky, but there is some contamination in there. And I can't even speak this morning. So let's look at one other thing before we go look at the tools we're going to need to. One thing you can look at, this is the oil filler cap. Now, you don't want to look at this too much and weigh this too easy on an issue. If you look at this, sometimes you can see indications of contamination. Now, there is a presence of water here, and it's probably never going to be impossible to tell on top of this white glove. But it looks like a milky yellow/white. Now, I have seen it several times over the years that Chryslers will get a little moisture inside this little cap. So if you do have that in there, I wouldn't necessarily freak out about it too much. In order to figure this problem out correctly, we're going to need some tools. Now, the tools I'm going to show you, granted, they are the higher end versions and they do cost quite a bit of money. You can get some regular cheaper tools, and you can even rent half of these from the auto parts store if you choose to. This set here, this is a compression tester. This tests the actual engine compression inside the cylinders. This can show that if there is a difference in pressure between one cylinder and another, that could be an indication that there's a blown head gasket. That is one tool that you can use. This is a block tester. Inside of here, you fill a special chemical fluid in there, and you put this on top of the radiator, you suck a little antifreeze up in there, and if the color turns as yellow, there is presence of hydrocarbons or water in there. Now, this is the primary tool that I'm going to first use. This is a cooling system pressure tester, and like I said, this is a larger set and has multiple adapters, such as these. You thread these onto either the pressurized overflow in a GM product or the radiator in this case. In this case, we're going to be using something such as this. You have to find the one that looks closest to your radiator cap. Once that's on there, this is it basically looks like a little bicycle pump. You pump it up to, say, we're going to go up to about 15 psi. And we're going to watch this gauge and see if the pressure drops, either rapidly or very slowly. Ideally, you don't want any pressure drop. I mean, if you have a little bit, okay, fine, but we're going to look for anything out of the ordinary. So I'm going to get this set up, and I'm going to show you. So we have our cooling system pressure tester installed on the engine. Now, you'll see a little pair of vice grips right here. This rubber hose right here, this goes over to the radiator, and the other end it goes over to a overflow bottle. This is not under pressure, and if you don't pinch this line off, you're going to get a false reading. So here's the adapter for this type of radiator. The hose obviously goes over to, well, the bicycle pump, if you want to call it. And we've pumped it up to about 15 psi. Now, it's only been about 30 seconds, and we've already lost pressure in the cooling system here. It's down to, looks like 12 or 13 psi. Now, this obviously will put pressure on the cooling system. Now, you're going to look all around the engine, all over the place, see if you can find any antifreeze leaking or anything like that. Now, Granted, this car has snow on it, so it makes it a little harder to see, but that's what you have handy-dandy light for. So you look all around the radiator, you look all over the place, see if you can find anything that you can either smell or you can hear a hissing noise a lot of times if it's big enough. Well, I've already done so, and I found no traces of an external coolant leak. So at this point, it's starting to look like it's going to be one of two things: blown head gasket, or the heater core inside the dash is leaking. So we're going to come over here inside the vehicle, open up the door, passenger side of the vehicle. Well, I've already done this as well. Get out in there with a light, we check the floor, make sure the floor is dry, we listen for any kind of hissing noise, make sure it's quiet in the environment that you're working in so you can hear what the hell you're talking about. Or just smell for antifreeze. Antifreeze is a very pungent smell. There's nothing in there. At this point, the next step we're going to have to do is we're going to have to do a compression test on the actual cylinders to determine if we do or do not have a blown head gasket. We're going to go back to our cylinder compression tester here. Once again, this is a higher end model, so yours won't look like this if you go rent one or buy one. Compression gauge is pretty simple. You have your gauge, and then you have probably just one lead that's going to thread inside there. Now, in order to do a compression test, you have to first, on this vehicle, you have a coil pack here. So you're going to remove the coil pack, and the spark plugs are underneath there. Now, I'm not going to show the process of doing that, but I'm just going to give a brief explanation of it. Once you take off that coil pack, you're going to find 6 spark plugs. You take out one spark plug at a time. Some people choose to do all of them at once. I choose not to. I choose to do one at a time. You're going to thread your small lead into the hole where the spark plug was, connect it to the gauge. At that point, you need to disable the fuel and or ignition system. Fuel is most important. In order to do that, you can either on this vehicle just unplug all the fuel injectors. They're all 6 there. They're pretty easy to get to. Or you could just pull the fuel pump relay located in this box here. I like to go one step ahead and disable the ignition system as well, so there's no way in hell that anything can even try to start the engine. In order to do that on a coil pack system, just unplug the coil pack. Pretty simple. Doing your compression test, you're going to get a piece of paper and you're going to write down the results every single time to do it. You don't even have to have an assistant to do this, I was going to say. You hold the gas pedal down to the floor and crank the engine going 1 1000, 2 1000, 3 1000. At that point, stop cranking, turn the key off, come underneath the hood, and record the number that you do. Every compression gauge will have a pressure release valve, which on mine is located right here. You push that, release the pressure, it'll go back down to 0, and do it again. You're going to do every cylinder twice, recording the numbers. Once you're done with all the cylinders, you're going to compare the numbers that you have received. You got to do a little math. The numbers have to be within 15 to 20% of each other. If there's more than a 15 to 20% drop, there is an issue right there. At that point, you can almost confirm that you do have a blown head gasket. I'm going to do that at this point, and then I'm going to report what I have. Ladies and gentlemen of the internet, the results are in. Unfortunately, they're not looking too good. So here is my result. Obviously, as you can see, I have 2 lines, compressed cylinders 1 through 6. And you can see the circled ones right here. Look at all the other numbers. Cylinders 1, 4, 5, 6, all of them are between 160 and 175, give or take. So those are good. Look at cylinders 2 and 3. Cylinder 2, first test, 110. Cylinder 2, second test, 105. Cylinder 3, first test, 115. Cylinder 3, second test, 115. These are well below 15% of the rest of these. So, being that their compression is low between 2 consecutive cylinders, we have confirmed that the cylinder head gasket is blown between these 2 cylinders. Now, if you only had low compression on one cylinder, that's more an indication that there is a mechanical problem with that cylinder. So, at this point, cylinder head's going to have to come off. So, it's not necessarily something that the average person should do. I will say that it is not the hardest one to do in the world. However, it's still something that's quite complicated. Once the cylinder head is off, we will be taking it to a machine shop where they will pressure test it and check for any kind of cracks internally that cannot be seen with the naked eye. If it passes the pressure test, then they will mill the actual machine surface where it meets the block itself. They'll machine it flat, So that way it won't blow the head gasket again. If you skip this step, you have a very good chance that your cylinder head gasket will blow again. You have to have this done. There is a casting defect on a lot of these inline 6s. This is the only issue that I've ever seen on these engines. They're almost bulletproof. Well, they are bulletproof. But every so often, I have done one of these engines, sent the cylinder head off, and there is a crack in the cylinder head, and I can't remember off the top of my head which cylinder it was, but it was always the same cylinders. So at that point, if the cylinder head is cracked, got to get a brand new head and install it. So that's what we're going to have to do now. Now we're going to have to alert our customer of our results. Unfortunately, nobody wants to hear this information, but I believe the customer was already partially prepared for this. Now, I believe we're pretty much done with our diagnostics of why this vehicle doesn't have any heat. Now, if you're watching this, please do not automatically assume you have a blown head gasket because you have no heat. There's many things that can cause that. Many things. If you have any questions, feel free to give us a call. We are located in Bedford Heights, Ohio, conveniently located at 21860 Libby Road. We're right near the intersection of Northfield and Libby Road, next to a PNC Bank. Our phone number here is 216-242-6066, and you're going to select option 3 for auto repair. And we are here Monday through Friday, 10 a.m. to 7 p.m., Saturday, 10 a.m. to 3 p.m. This is Chris from Bedford Heights Auto Service, signing out. Well, here we are, about 4 or 5 hours later. Obviously, same vehicle. And heads off the block. Customer made the customer aware of the situation, came in, signed the paperwork, and paid his deposit. So there's the block, and here's the cylinder head off. And unfortunately, this is an example of poor maintenance. Not on the person who brought the vehicle in here. He just purchased the vehicle, so this isn't his fault. But you can see in here how oil just sludged up this cylinder head is, unfortunately. This is just a perfect example why you need to change your oil every 3,000 miles, or else it's going to look like this. So unfortunately, now what's going to happen is this has got to go to the machine shop anyway. But the problem is now it's going to cost more money because that cylinder head is going to have to be seriously cleaned, extremely cleaned. Get all that stuff out of there. Get all the ports extremely cleaned out because everything is just sludged and burnt to living hell. Here is the rockers. Same thing, completely sludged up. And the push rods, same thing, sludged. There's the intake manifold and the exhaust manifold, along with the downpipe still on the ground there. Generally, I pull these things out as an assembly because it's relatively hard to get to the bolts because they actually all go on the same side of the engine. These are intake and exhaust ports. So you pull as an assembly. Please note that it's a good idea to have a little bit of help. Unfortunately, I didn't have any help, so it made it a little harder. I actually ended up using my cherry picker over there, try to get it out of there. But now that that's all taken apart, I need to clean the antifreeze that spilled into the cylinders, clean the top of the head real good. I'm sorry, the top of the block real well. And tomorrow morning, cylinder head's going to go off to the machine shop, and we're going to have them pressure test it, make sure it's all good, and clean it extremely well. And hopefully it won't need a rebuild because of all that, but I guess we're going to find out. So this is Chris from Bedford Heights Auto Service. I think I'm going to end the video at this point. Have a good day, folks.